Ladies and gentlemen, good evening. Hello, welcome to Dr. Döding's Computer Electronics Laboratorium. I forgot the little mouse. There you go. There you go. We have to have the little mouse with us. I'm so confused about this. How to actually, charge here these lithium batteries. And whilst waiting around for the lithium iron phosphate cells that I will build into a battery for the caravan, I figure I must experiment a little bit and try and find out what's what with this stuff. So what I have here is a lithium-based, I think, power source for some incredibly cheap Chinese electrical drill that I bought many years back from AliExpress. I don't think it ever works properly. Maybe it worked when it was new, but then it sat around for a long while, and I think that this is dead, or at least one or two cells in it. One or more out of the 3 cells in it might well be dead. So to have something to do here whilst we're waiting for the lithium iron phosphate cells to arrive, I think, and see if we can actually manage to charge one of these here cells, and if we can manage to set up one of these here little power supplies, constant current, constant voltage power supply things. So I have a 12 volt power supply coming in from the wall over there and going into this thing, and this has two little potentiometers on it. One is for adjusting voltage and one is for adjusting current. And if I'm not completely misinformed, which I may well be completely misinformed about this, and we will have a little bit of an accident, maybe, we shall see. The way you're supposed to calibrate these for the current you want and everything, you're supposed to simply short the output with an ammeter to see, and thereby set the current, which sort of makes sense. That would be how you'd set the current, because how else would you set the current? But then it also seems just a little bit, purposefully creating a short situation and such. It's just not something that I want to do, but there you have it. That's what we're supposed to do now here. So purposefully shorting out a power supply, very cheap Chinese made power supply. There seems to be a theme here. Cheap Chinese crap. Yep, we're doing best price. Just as Chinese. That's what we are now. So first of all, we can see here. Can you see the multimeter over there? Not quite. If you can bring it in a bit closer. There you go. I should have turned them down all the way. There, both of those potentiometers. And just turn this on first and see what we have on the input. If we actually have that, should be a 12 volt power supply. Is that what we have? No, 12.8. Close enough. Close enough. And then here, this should be output negative, and that should be output positive. Yes, it is. At least if the board is marked correctly. There, framing your shots here as always, very good. Okay, and I also have this. That's the voltmeter. This is the ammeter in this case. So I should move this to there and put this to 10 amp unfused mode. What could possibly go wrong? I suppose the worst thing that could happen is like one of these electrolytic capacitors would blow up and throw its electrolyte in my eyes. That's about the worst thing that could happen, I would think. You can use your imagination as to other possibilities here of things that might go wrong. That's positive, and we hook up hook up the test probe from the voltmeter to there. There's a little alligator clip, and then the positive to the ammeter too. Now this is where it gets a bit sketchy. But this is apparently how you're supposed to do it, supposedly. I mean, I don't have the most strongest sources backing me up on this, but yeah, it's turned down all the way. The voltage is turned down all the way, current is turned down all the way. So, I mean, if this thing is actually working and it is limiting, not a whole lot should happen here, because we shouldn't get a whole lot in this short circuit, right? No, not a whole lot, but you might still get something. And also, we're trusting that this thing actually works. Maybe not, but that's it. It is now short-circuited there, and we have amps and we have volts. So I can get a little alligator clip there to hold that on for me. Come on, mate. I didn't want to. Can you be persuaded to want to? There you go, maybe. There you go. Come on. I would prefer a slightly more solid connection here. Or maybe I wouldn't prefer a slightly more solid connection. Maybe I should start by just doing that to it. If there is smoke or something, we can start there. There. First of all, what do we have? 1.25 volts, short it. Okay. 8 amps, 10? Yeah, so that's 10 watts now, then that is going somewhere. And then, where is this going? All this current? Something... this thing is heating up, the lead here is heating up. I think that my test probes are the thing actually limiting the current as of right now. So what you then should do, counterintuitively, is to adjust the voltage up. This is just a bit insane. First adjust the voltage up, because that will allow the thing to settle, they claim, just by a few turns. Really. Ugh. Yeah, okay. Current is going down now. Yes, there you go. Voltage is down to nothing. Current is down to negligible. 370 milliamperes. That's I'm more comfortable with having here as a dead short. Right? Okay, now comes the funny bit then of adjusting the current to what we should use for actually charging these here lithium cells, and I'm not quite sure what that would be. Then see if we turn this up now. Can you see that? Yeah, you can sort of see what's going on there. Is the current? The current isn't increasing, mate. Oh, there it comes. 1 amp. Yeah, 1 amp. That will do for now. And then we can set the voltage too. Should you do it under load or without load? I think they should do it under load, right? Because that's quite heavily. If I disconnect, the voltage is 1.5 volts. If I have this connected, it is not a whole lot. So let's say voltage is that one, the outer one. And I suppose 4.2 is the maximum for a lithium ion cell. I'm not going to go quite that far though. Something is making a whining noise, or should I disconnect it? Maybe that's what I should do. See here, so I won't go quite that. It's unnecessary to charge it up completely fully. So we'll set it to around 3.989 volts. Now what sort of current do we get if we just put that on there? 1 amp. Yeah, okay. Can turn the power on off again for now. Let's see if we can get the cells out of here. Or one cell, or get something out of here. That was way too large a screwdriver. I need something. A Phillips head that is rather small to get in there and to get access to this here. Like so. That's it. Yeah, Dr. Dooley is always well prepared in the tools department. Yes, but come on, but this won't give me a whole lot of torque. Wait a minute, I'm gonna go get a little toolbox here. There, this should be able to. In this professional's kit, we should be able to find some combination that should do it. I think that one maybe. Might be just a tad on the pointy side to actually do this without either ruining the very cheap, very poorly made bit, or the likewise really poorly made and really cheap screw head. See, can we? Yeah, okay. And if this is dismantleable at all, I don't know. But since there were these 3 screws hidden behind a sticker. That's a good sign. Let's see. Okay, yeah, there is indeed three of these here 1860s, whatever they're called. How do you get these out? Can you get them out without ruining the thing? Yes. Oh, right. This has a charger built in, supposedly. Now, can we get to these cells here without, or how much do I have to destroy this thing in order to be able to access this? Is this like welded on, or what is this? Oh, you can remove this. Yeah, it would seem so. Oh, there you go. We have access. On the other side is going to be slightly more cumbersome though, because this whole thing is sort of in the way. The charger, whatever it's supposed to be. Oh, yes, and it goes like so, and there too, so it's not going to come off really easily there. No, but oh, well, maybe we can access all that we need. Not really, because this cell is not going to be easy to get to. And I would like to, if I could get this to charge and thereby have the drill working again. I'm thinking of using that to maybe raising and lowering the corner legs, or what they're called, on the caravan. But see if we can measure the voltage here of each individual cell first and foremost, and see if that is indeed the issue. That one of them is too low for this here charger to do its thing, right? That's what I was thinking anyway. Come on. There, what do we have? Nothing. 4.05, that's basically fully charged. That one. Right. What about this one? .8. That's not great. I can't remember off the top of my head here. I'll ask the Book of Knowledge. Lithium ion cell voltage. Book of Knowledge, tell me. Yes, lots of information. Just tell me the like nominal voltage 3.7 volts. Sure, very good. Max charge rate 1C. Yes, whatever. Charging technology. Yada. Yes. No, not really. Oh, here's a nice curve of something. Okay, so what did we have again? We had 2.8. 2.8 is really not great. No, that's sort of below. That's around like 15%. I mean, it's not completely depleted, but neither very good. And this one, finally. Oh, 1.75. That is rather dead. Right, that is rather dead. Okay. So that's probably the one that we should start with then, if you want to try and see if we can get the voltage going up here or something. Right. Yes. I mean, I would really prefer to get all of this out of the way and thereby know for sure what I'm connecting to, that I'm connecting to only the cell and not making a circuit here for somehow. It was this one, right? That was bad. 1.7. Yeah, 1.7. I should have a little pen. Thank you. And I shall simply write on it here. 1.7 volts, obviously. There you go. Volts is about as redundant as saying it's 23 degrees Celsius. Yeah, well, duh, it's fucking Celsius. Only fucking Americans know what the hell Fahrenheit even are or how that works. It's nonsensical, stupid system. Just get off it. Seriously. Oh, it's in the 70s, it's in the 80s, it's in the 90s, it's 100. What the fuck does that mean? No one knows. Only you. I need to concentrate here on these here batteries now, so not as to cause. I wouldn't want to burn my house down or cause an explosion. 2.8 at that one, and now we only had 3 point something here. No, 4.05. Well, that's great. 1.7. See, can I get to that? I suppose I could stick a wire in. If I stuck a wire in there, jammed it in there, and then connected something there, then this little thing is connecting it to something, and I'm not sure how this all works. Don't quite feel like reverse engineering this whole thing this hour. And so on. There's also a little thing coming up here, which may well be welded to this cell. Can we find that out? If that is the same, see if we measure there and there, for example. Yeah, it ought to be the same, so that might be a slightly safer spot to to connect it to. Yeah, it may well could be. So these are 1865. That is not the capacity, right? That's the size of them, isn't it? Yeah, I don't know what the capacity is. Doesn't say. What did we say? I think I set it to 1 amp. 1 amp at roughly 4 volts. That's 4 watts. That's not going to not a terrible amount of things is going to happen there. I think so. We can turn that on and see what we got. What I set it to 3.9. Yeah, sounds good. Safe enough, I would think. And 1 amp. I could even adjust this down even slightly, just to be safe, or possibly be safer. You can't see that anymore. I'm sorry. 0.9 amps at 3.9 volts. That should be very conservative, I would think. What did I just do? That's apparently how we're supposed to do it then. Turn the power off again, and now then, I need to get the wire onto that little thing there. I'm going to get cut these up. Which side was the positive and which was the negative? This is also quite important, you know, to get right. It has a plus and a minus, so we can assume that that's correct. Yes, that is correct. Okay, so we want a little bit of red wire then. This is thicker than it needs to be to pass 0.9 amps. That's for sure. There we go. And wire stripper. Probably want it just a little bit longer. Right there, and see if we can get this underneath here, and hopefully this board might be, might have components on the other side of it too. You never know what you might. I mean, if I did something like that, is that I might not be prudent. You know what to do? We take out just a few of these, like that maybe. Let's see if we can get these in there. You're sure this is safe? What you're doing here? No, I am not sure that this is safe. In fact, not in the slightest. I'm reasonably sure that it isn't terribly, incredibly unsafe, and I'm not going to leave this unattended overnight. And see if we get something, and then I'll turn it off and start it back up tomorrow, when I can sit here and monitor it, at least with a half an or a quarter of an eye or something. There you go. As long as that doesn't jiggle about too much, that should be safe-ish. What should we do? Around this. At least something there. But now you did put I put the red wire on the negative side. That is sure to cause confusion. Now we undo. Do it again and do it properly. There we go. Remove that and get this one on instead. Boop, 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 boop. There we go. Use this already stripped end, if that is necessary to have it quite that long. It might be. There you go. And feed that through there without it catching on anything else and thereby causing terrible dangerous problems. There, and then electrical taping, just a bit of it here, like so. There, that is our negative coming out of the battery. Hopefully, could be. There you go. Making a mess, mates, as usual. Yes, that's sort of my forte here and what I do. For it's part of the thing, unfortunately. That's just the way it goes. And we also need to connect the positive then here somehow. And well, technically all of these are the same point electrically anyway, so I could wire it around here, I would think. Couldn't I? Yeah, I think so. That ought to be good, as long as we're only really connected to this cell here and nothing else. That should be fine. And how sure are you about this? That's the only thing that you're connected to. Not completely terribly sure about that, because it goes on further on to the charging board and whatnot. So not really at all would be the answer, really. But yeah, it is what it is. There, and a further piece of electrical tape. Am I in shot at all? Maybe a little bit. Maybe a little bit. There you go. So this should now be 1.7 volts or something here, if we're on the right track, and we can do the polarity correct as well, so we don't need to be confused about why it's showing up as a negative. That's 0.7 volts. No, it's not. It's 1.7 if you actually do the connections properly. Right. Okay, and then we need the amp meter in series with the thing. You can use that like that maybe, and see if you can have the mouse over there supervising. There you go. You can have a look. Yeah, you can case upon the meters. There. Now this feels a bit sketchy. Yes, not. I mean, just hooking up to the terminals on this here cell. That's all right, but then it's also connecting to all of this stuff, which does go onto there. Maybe I should cut this cable. I'm not sure what it does. See if we can find out what that does. Put that to resistance and let's see if we can get a bit more clever on it. Does it go there, for example? No. Does it go to the ground? Not really. Am I still on the right place? Yes, but it says that it has 7 ohms of resistance from this here thing to that there thing, which, as far as I can see, should only be a tiny wire, and I'm not sure I'm buying. Or it is this meter, which is complete rubbish. Yeah, it says that it has 7 ohms in the test leads. Can we trust it for voltage even? This is rubbish, this meter. In case I didn't already explain. See if we, yeah, considering that it is rubbish, set this one to voltage. This is an over 20-year-old thing that I got in high school. Not that we have something called high school, but believe something that is sort of the equivalent anyway. Turn that on and see what we have here. Oops, that's still set to... I need to move that over from the current measurement to there, or you'll short it out. Yeah, I might have blown a breaker or two with that in every now. Yeah, but that's okay. So voltage it seems to be able to do 3.87. Yeah, they are reasonably in agreement about this, at least. So there you go. We can measure current on the return side. Why not? There, and strip a bit more of it. There. Now we wind that over here. There you go, put that out of the way of anything. There, for example. And then we take, yes, that should come out of here then. Yes, you sound a little bit, just a little bit, tiny bit not uncertain, but the power's on, turn that off. I'm not completely comfortable with what I'm doing now, even though we are dealing with low voltages and everything. I don't like things blowing up in my face, really. Right, we have negative going through amp meter to power supply, positive coming out of power supply, going into battery cell here. Right there, yes, and then we take these, twist them together, maybe a bit, and take the probe. There you go, twist them around the probe. Yes, there are better ways of doing this bit here, more reliable and safe ways of doing it. But I'm trying to cobble this together here now, just to I'm so a little bit frustrated about this here charging of lithium cells and the magic of it, which seems to be at least a little bit of magic surrounding it. So I need to figure it out. And what better way to figure stuff out than to do experiments? Okay. So is this is it then? You're like comfortable applying power to this now. Full mains power. So this here very good Chinese power brick through this very high quality Chinese buck converter with voltage and constant voltage and constant current regulation. We now have 1.57 volts. There for some reason. It would stand to reason that it should have very much similar to what we got. I don't see how this would differ a whole lot from what we had previously, but just in case something is flowing back into the buck converter, okay, when I took that out it went up to 165. Okay, so something is flowing back into this thing. So we might need a diode or something here too, sometime under some circumstances. But anyway, but then again, why aren't you showing anything? The voltage goes down when I plug this in to here. Okay, anyway, that should be the positive side of the thing. That should be the negative side of the thing. Ammeter, yes. Yeah, okay. See what happens. Okay, voltage went up, but we're not getting a whole lot of current, if any at all. Is this getting hot? No. no current is flowing, mates. You're getting voltage, but no current. Turn that off again. This doesn't feel right. We should be getting current here. Yes. Yes, we should. What's the matter? So if we do a dead short again, so we just have this ammeter plugged in there. Oh, what happened? Ugh, it's moving. It's probably only my poor job of taping this down and nothing else. Yes, but did I destroy my ammeter or what? It doesn't seem to be. That goes to there, that goes to there. No, 0.8, 0.89. .89 amps. Okay, well, coming off the negative of the battery then, please, if you wouldn't mind. And yeah, real solid connections here. All of them are incredibly solid. Let's do this again. Make it try and make it a little bit more properly, at least that we did first time around. There you go, maybe. It's showing 1.9 volts, so we might actually have gotten a little bit of charge into the thing, but this really says that no amps are flowing here, while the voltage is indicating that stuff is happening. The thing is not going to help you. This might. There you go. No amps. None whatsoever. I'm not sure I'm liking this very much. Just do a little finger test here if anything is getting. Nah, it's not getting hot. It's not. It is providing 3.9 volts though. Yes, and if we short that thing, that is limited to 0.89 amperes. Something happened. Yes. So if we just carefully turn up the amps just a little bit. I don't think it should be necessary to go about 3.9 volts. Careful now. No, not really. Okay. Turn the voltage up just a little. There we go. That's enough. 4 volts. Why isn't this quite working? Or why am I not seeing? Do I have this in parallel somehow? No. The negative from power supply. Yes, it goes into this probe, or this one. That is hooked up to the power amperage meting thing. Is there something loose glitch in this? No, seems alright. What if we break the connection? Yeah, then voltage changes significantly. If we break the circuit, that is. So, it could be the power supply that isn't performing as I'm expecting it to. I don't know what to expect from this. Should we turn it up a little bit more? Current. And try and do it carefully, whilst carefully watching, observing both the voltage and the current. Nothing really. Don't want to do more than that. There we got something. I mean, if we're doing it at this rate, then 200 milliamps I can do via the fuse in here. But now you want to do quite a bit more than so. I mean, is anything happening? You know, I am not sure. I really am not sure. Do you need high voltage to break on through? Which I don't know. Or does it, since it is so very, very discharged? That's the current. Yeah, this is the voltage. Should not go above. Nothing's happening. Are you going to blow something up here now, mate, if you're not careful? Okay. I either leave this to it for a while and see if something changes. This shouldn't be dangerous, at least if this is to be trusted. If this is to be trusted, nothing, absolutely nothing is really happening here, except that we're providing a voltage of 4.16 volts there. But no currents flowing, really. Oh. Okay. Okay, we'll remove this probe again from the ammeter carefully. There we go. So now we've broken the connection, and it is floating around now at 2. So yeah, the voltage of the cell now that I removed is now my charging circuit is broken. So now we're only getting the voltage of the cell. So that has that increased to 2.7 volts. I mean that would be an improvement, I would think. See if we do that, what do we get now? A lot. Ugh. 2.45 amps. That's a bit more than I'm comfortable here with, so turn that down a bit. Turn it down to around 1.9, say. There you go, and then we hook this up again. There, completing the circuit, yes. It's a tiny amount of current that is flowing, if any at all, here. And this connection should be, this should be good. And the voltage of the cell did increase, so that's something. Maybe we should leave it like this for a little bit, and yeah, I'll get back to you here shortly and see what we got in a little while. Which means I'm going to walk away from this. So if it catches on fire, you'll be the first to know. I'm totally comfortable with all this. How are you doing here, little friend? Nothing really has changed. There's no heat here. There's no heat here. Nothing really. Okay, I'm not so sure about this. Turn voltage up, maybe. Don't know. Just a little bit. See if we get anything happening. No. Well, okay, maybe. How far do you dare to go? Not a lot further than this, mate. No. No. Okay, we turn it back now here. Is anything happening? Is anything getting hot? Is anything... No, nothing could get hot because no current is flowing according to you. So how would it get hot? It wouldn't. And the ammeter is working. Yes. If we were to bypass it, just for sake of... I don't know what, but for sake of something. That would be happen if we did this. Is that in shot? It's sort of in shot. Right, yes. Okay. Nah, nothing of significance happened. Nope, this isn't working. And then this thing might be faulty, this cell might be faulty. It is probably faulty since the voltage is quite low, but 1.7 around, well, that is maybe outside of the range of the thing. We had another cell that was low, but not that low. What was it, 3.8 something? So it's not even low, that's just not fully charged. So we can try, see if we can charge that one instead. Now if we turn the power supply off and see what voltage this cell will be resting at, maybe. Resting. I think that we're still getting something from the power supply rather than anything else. The little LED on this thing is still on. But we need to disconnect most of this anyway. Well, we can do this. We can just disconnect here and see what that shows us. If we take that out, that should show us the cell voltage now. Did you see that's a lot higher than it was previously? 2.8 volts. 2.8. That's promising. So the voltage has gone up, but how? how would the voltage go up when no current has gone through? Really? See, I don't know. But it definitely has. Somehow. Right. Yeah, it sure has. Okay, see, thank you, away there, thank you, and just do a clean measurement here of there and there. 2.7 now, and you were at 1.7 before, right? Okay. We could do something a little bit simpler here without having to change these wires. I'm thinking. See here, which was the next cell that was not great, but not hopeless neither. 2.8. Sharpie. Sorry, out of shot. And blocking view. 2.8. Yes, and positive is down here. No, positive is up here. Right, because it was showing it as reverse polarity. Yes. So then you should, if you wanted to try this a little bit, just quick and dirty. Quick and dirty. Sure you want to do things quick and dirty. I just want to get somewhere on this. This cell shouldn't be like hopelessly destroyed, at least. This should accept a charge, I think. You see what we're at here now with the power supply. Can we turn that on safely? Yes. Voltage probe, what are we at? At the thing here. We're at 4 volts. Okay. And if we do current, short circuit, what do we get? Same as before, 0.89 amps. Right, then. Okay, turn it off again, and we can hook this up as we did the previous one. Might not be as easy here. No, but we can pry it apart a little bit maybe. Like there you go, perhaps. But wait, yeah, this makes sense. This makes sense. Because those they are in series, all of these three here. So it would make sense that one had a positive there and this one has the positive there. Yes, that makes perfect sense. Okay, so try and work this through there. Very good, very safe. Very safe. All of this is very safe. No. This may not be safe at all. This might be dangerous. I don't know. Lithium cells, especially these are lithium ion cells, so it can supposedly go up in flames and explosions and smoke and whatnot. So I don't think that this is the recommended way of trying to figure out how to charge lithium cells. You could definitely probably learn how not to charge lithium cells by this here method. There you go. That should be positive from this one, and this should still be negative still. This is now negative for this one. Yeah, that's not going to be confusing at all. Let's put a little plus sign there. Short. No, don't do that. That's not something that you want to do. There, take this and see if we do that and that, we should get about 2.8 volts. Yes, this is the positive of this here cell, right? And we connect that up like. Do you know what you're doing? Well. Yeah, I kind of know what I'm doing, but yes, okay. I know what I'm doing, but I'm very, very much uncertain as to what sort of result one might get out of doing this. That was the positive, right? Positive. And we can also then do, I'm one lead short now here all of a sudden. Screw it, we do it this way. Then. Am I not one lead short? I think I am. So I want to have voltage measured there. Right, and yeah, and then you could screw this into the power supply then, I suppose, which is off, and the LED is off. There you go. And then we complete the circuit by hooking up the ammeter, which is, yeah, it's connected to the negative on the power supply, and we take the positive from the ammeter and connect it to the negative on the cell. Yes. And you're not showing a voltage because this one is not connected. This should also be there. Yes. Right, so this should be pretty much the same setup as we had before, just with a different cell. Okay. Now we're getting amperage, and the voltage went down, and I think that we're actually charging this now by 0.8786 amps. Okay. Well, that's a result. That is a result. Is it safe to charge these at this rate? I don't know. Because I don't know the capacity. I don't know the C rating. It's not heating up so far. It's not going to heat up, mate. You at maximum, you're getting like 3.5 watts here or something. And if none of that went into actually charging the battery, but only went into heat, then it might start to heat up about now. But yeah, I think that we're actually charging this one now here at the voltage of 3.7576. It's going up slowly but surely at an amperage or current of 840 milliamps. All right. We did, however, manage to get the voltage up slightly here. So I wonder if one can revive this. How do you revive lithium-ion cells? Reviving ion cells. You just connect the battery to a voltage source, 3.5 to 5 volts, and charge it for around 5 minutes to get the voltage up. Once that happens, you can put the battery inside a charger and get it to charge normally. One caveat is that you should be present when you do this the whole time. Yes, I wasn't quite present, but then I was not hooked up to just a regular constant voltage source. I actually had a current limit. So, but that one is getting up there, 3.9495. That one is charging. That's pretty cool. What I would like to know next is what happens when we start to approach, when the cell approaches the set voltage here, 4 point something. If the current goes to zero, or if it continues to trickle for forever. It's starting to go down, which is good. Yeah, we're charging it. I'm charging a lithium cell. Wonderful, he said as it blew up in his face. No, but it's not going to blow up in my face because this is pretty well within defined parameters, I think. Except I'm not too sure about the current. If that is too high for one of these here tiny things. But we did get, since I did get the voltage up on the other one, I mean, it should be possible to cram a bit of power into it too, maybe. Yeah, this is great. This is a result. Amperage is dropping, voltage is rising. This thing is not warm to the touch, which it ought not to be under such a low load. Which Dr. Pluring is charging batteries here in the electronics laboratorium. Wonderful, magnificent, fantastic. That only took an hour. Yeah, I want to go back to the other one, the dead cell, and see if we can bring that back to life or something. There you go, amps has come to nothing, voltage stabilizing at around 3.8, or yeah, so, and it was at 2.8, so we got it up by 1 whole volt. Okay, right, careful now here and think things through just a little bit what you want to do. Yes, we're going to reverse and make things different because this one is not supposed to be connected anymore, and instead we have this one, which is the negative of the dead cell, or hopefully not dead, hopefully only slumbering. Maybe the connection here isn't that great neither on the terminal. Looking at it now, turn it over that way and fold that one away. So we have negative there, we have negative there, and previously the way I had it this one. It went like that. From the negative to on the cell into the ammeter, from the ammeter to the negative on the power supply, and then basically we just need to hook this up to the power supply too. Careful, no, you maybe damaged a capacitor. I didn't damage it, but I disturbed it. Yes, this is very good to do that connection right there. Yes, nothing could go wrong. There you go. Is that it? Let's verify here. Positive out of the power supply to positive of battery, negative out of the battery through ammeter, yes, out of ammeter to negative on power supply. And my voltage meter is not hooked up, unfortunately. There you go, we have 0.1. Maybe if you left this to it, something might happen here eventually. But I'm not going to leave it. It says here on the thing that one caveat is that you should be present when you do this the whole time. Yeah, so you can get the thing to blow up in your eyes. But yeah, we actually have a current every now and then. A little bit of current is flowing. And all of a sudden, this might jump into just spring into life. We increase voltage a bit. See if we can get it wake it up carefully. Wakey pakey. I won't go higher than so. I did rise to 2.8 volts, which should be good. Should be accepting charge at that level. Yeah, but I think I'll leave it here for now. And come back to this tomorrow where I can be supervising it a bit and just shut it off as it is and maybe unplug one of the leads here just in case. Yeah, I think that will be that for now from Dr. Plurings Computer Laboratorium, Electronics Laboratorium, battery thing, experimentations. There is only one way to know, and that is to find out how it actually works. And we're getting like 10 milliamps every now and then. Yes, and it seems to be gravitating towards having an A1 here more often than a 0 at this point, isn't it? We might actually be able to get this thing alive, and I might be able to use that drill to lower the support legs of the caravan. That would be lovely. Not have to use that crank thing takes forever. You see, it's almost stabilized at 10 milliamps, hasn't it? Oh, now it's gone the other way again. Yeah, but this might take a while. Well, I suppose all of a sudden this will zip. Yeah, get off it now. It's too late, mate. You should go to bed. Yes, turn it off, go to bed, start it back up tomorrow when you have to sit here anyways. And you can almost not keep an eye on it from your workstation there, but you can keep a nose on it, and if it starts smelling or something, then I'll notice. I can maybe turn these around and I can see them from over there. Okay, well, that was something. I think I learned something actually here. I was able to charge that one, the healthy cell. That did definitely charge. I want to do that further and see what happens when the voltage of the cell approaches the set voltage from this thing. But yeah, and this just left alone for enough time, this might actually get somewhere. Ladies and gentlemen, thank you so very much for watching. Good night and cheerio. Right there, ladies and gentlemen. What have I learned here as regards to charging these here lithium cells? Well, I think that one of the cells is like completely dead. The one that had a really low voltage of 1.7. See what we can do here. We can, if I bring this, hopefully see if we can bring it in shot, maybe. About there. Multimeter blue for scrap warehouse there, and then sort out the leads. This was at 1.7 when I first started. See what does it show now. This ought to be the correct polarity. 2.12 volts. So yeah, that seems like hopeful, right? That it ought to do something, but no matter for how long I leave this, it just no current goes into it. however I tried. This one, however, which started out at 2.8 volts, that one is actually, I managed to charge here with my this thing. See, it's 4 volts. That's pretty much fully charged. You see the completely healthy cell. What is that at? About there, 4.04 volts. So that's good. Maybe we should make one final attempt at this here quite broken battery. See if we can't. I have very small hopes of actually being able to charge this. I've scrounged around try and see if I could find any of these here cells anywhere in the house, but I know really the only thing I found that would have these cells in it was I can show you just a moment from an old laptop, a very old laptop indeed. There you go. This almost belongs in a museum. A ThinkPad X61, I believe it is called, and this is incredibly old. Is what it is, but it is still working. I'm not using it for anything. I can't even think of something to use it for, because it's, by today's standards, this is incredibly power hungry and unsuitable. It's really lightweight. It's going to be terrible by today's standards and everything, but I can't really get myself to destroy it. But I have the battery is of course removable. The battery is here. It's not the original battery. Unfortunately, I think I threw the original battery out. Otherwise, I might have been able to harvest a cell or two from there. But I probably threw it out like 10 years ago. And this battery accepted a charge, and you can see. I think that it will actually run from this battery. See, can you see it? Yes, you can somewhat see it. Push the on button, yeah. So there is no hard drive in it for the moment, so not a whole lot more than that is going to happen. But there you go. It's actually working off this very old battery and everything. So that's good. These were, I think that this is like the first generation of Lenovo's when after IBM sold it. So this is still pretty much an IBM design, if I'm not speaking completely out of the behind, which is very possible that I am doing. But anyway, the reason I would want to get this battery pack lively again is so I can use it for a very cheap little drill. Yes, we already said to lower the support legs of the caravan would be nice. Anywho, that is the bad cell. That's the negative coming out of it. We have this one for measuring current. If you put that there, and then maybe we can prop this up somehow. So turn you around here, and also close the lid on it maybe. There and there. That ought to do it. There you go. So we do, this is the negative. Yes, it is. So we hook that up there, and then we hook this one that goes into the power regulator thing. That should already, that should, from previous adventures here, be set to a reasonable thing, I believe. Let's see here now. I'm a little bit cloudy in the head as it goes. Yes, negative battery, positive of battery here. Yes, you should. Yes, this. You hook this end, or plug this end of the thing into the voltage regulator. Constant current, constant voltage thing. Oops, I lost the screw there. So it can reattach that somehow. Hopefully, as usual, a magnetized screwdriver will make really easy work out of this. Now it is a bit more fiddly. Yes, there you go. You might be able to Come on, mate. Hey, that's where you want to be. That's where you were made for being. So, yes, thank you. Just a few turns, and then I can jam that in there, like so. And see, now we need to complete the circuit. The circuit is not complete quite yet. No, here. So from the negative pole on this here cell, we're going through the ammeter and to the charging thing. I think this should do it more or less. So we plug the power, we turn the power on. What could go wrong? Nothing happened. That will be because this is not actually plugged into the thing. Mouse, yeah, you're inspecting it close up. Very good. There you go. 4.11 volts. 4.10 volts. Absolutely no current. Every now and then it flickers, but I'm not sure if this is actually just the meter that has a bit of funny business going on with it or what. We can try experimenting here a little bit by turning the voltage up. Maybe I think the current is limited to about 0.4 amps. And if I turn the voltage up to like 5 volts, can sometimes get the current to get up to even 0.02 of an amp, 20 milliamps. But this, I don't think this is safe. That you're supposed to do this to these here lithium cells. I don't think this is recommended. It's ill-advised, maybe even. Yeah, so this one is dead for some reason. I should maybe be wearing safety goggles if I intend to be doing this. Yeah, so that's hopeless. I don't know what's wrong with it. Something is wrong with it. It isn't working. Tell you that much. However, we do have two of the cells are now reasonably fully charged, which ought to bring the thing up to about 8 volts, but they are in series, so the current would have to pass through this one that doesn't seem to want to pass any current, really. So I don't think that it's going to work. How high do you dare to go here before the thing starts smoking? How could it start smoking though? Because there's absolutely no current going through, so it couldn't really heat up, at least not from the energy I'm putting into it. Or if it does have some sort of latent chemical energy in here somehow, that could maybe explode. We wouldn't want that, now would we? No, it's just hopeless. However, I did learn about the other one, the healthy cell, that if I have the voltage set like so, maybe like 4.2 volts is usually the recommended voltage that you charge these two. But I figured if I turn that down a bit to like about there, 3.9 say, and still have the current limited, what will happen when the voltage of the cell reaches this level? The current goes down very much. It doesn't go down to absolutely zero. And then Googling this for a bit and reading on various places. I mean, it's hopeless to Google things nowadays because you only get advertisements to buy stuff. Where are all the results from all the forums and everything where there's a wealth of information gathered? It's just hopeless to find. Google is useless nowadays. They really should do something about that. Try and make it useful again, maybe. Otherwise, no one is going, in the long run, no one is going to go there and see all those advertisements anyway. But anyway, some people say that, no, goddammit, you stupid person, you cannot have a lower voltage here and then just leave it trickling, because it will continue trickling a very small amount of power into the cell, and that will ruin the cell. That was one person's opinion. Then another person comes along and says the complete opposite, that this is healthy for the battery. This is an excellent way of charging the battery to almost full Because this thing that most chargers do of using 4.2 volts as the fully charged state level, say. But what they do, those chargers, is that they bring them up to 4.2 volts and then they hold them there whilst the current is going down. And when the current has reached a low level enough, whatever it is set again, I don't have the numbers, but then it backs off the charging voltage by to maybe 4.0 or something. And then the cell settles down a bit, and what they usually do on the chargers is that they bring them up to 4.2 again to get them really fully charged. So some people say that this stresses the cell unnecessarily. It will charge them quicker and so on, but charging them to a lower voltage and then keeping it there is more healthy for the cell, because you're not stressing it by taking it up to 4.2 volts. But then again, these are not facts. These are opinions from people, and people have completely differing opinions about these things. So I'm not comfortable enough with how the chemistry is in these here lithium cells. But if it would have been if they would have worked the same as a lead acid cell would do, then as the state of charge went up, the internal resistance of it would also go up. So even if you left it at about the voltage where it eventually settles, when it is fully charged, it isn't really a problem to have a bit of current trickling in. For one thing, you sort of need to do that to keep a lead acid cell fully charged, because that has quite a significant self-discharge. But also, since it does have a significant internal resistance when it is fully charged, what happens to that current that you trickle into it? It turns to heat. It keeps it topped up, and what doesn't go into keeping it topped up simply heats up the cell a little bit. And when you're talking like a few like 100 milliamps at a low voltage, that's not a lot of power that you're putting in, and that heat can easily dissipate away into the surrounding environment. So I'm still not sure of how I'm actually going to solve this for my caravan battery. However, I think that the lithium iron phosphate cells are the same in that the internal resistance does not go up and so on, and so forth. Thereby by the battery's chemistry, it sort of has a battery management system due to how the chemistry works. It's the same with the lithium iron phosphate cells as it is with these ones. However, the phosphate cells should be a lot more sturdy and a lot less prone to fires and explosions and things like that. And maybe then I could have the solar charge controller that is intelligent enough to raise the battery voltage up, and when it has reached the full state of charge, or something very close to full state of charge, it can back off a bit, so that you still have are able to draw power from the solar cells for any loads that you have at the moment, whilst also having the battery topped up. And if you draw more power from the solar than what it is able to provide, voltage would drop in the system and current would flow out of the battery. And eventually, after a little while, that would trigger the charge controller to raise its voltage again to top it up. That's how it would work during the day for the solar charge controller. But then I also have the DC to DC charge controller from the vehicle, and also an AC charger which puts out DC. And I either need to have, in that circuit, I either need to have the same intelligence that takes the cells up to a specified voltage, and when they have been there for a while, the current has dropped, they take the voltage down. Or I could do away with all that. Maybe I can just say screw it about that and have them, the voltage that is applied by both the DC to DC charger and the AC to DC charger, a little bit more conservative, So maybe say that you to fully charge a lithium iron phosphate cell, you bring it up to 3.65 volts. So that's your voltage that you set. If I set that to like 3.45 instead, and have it current limited as it is charging, it won't charge as quickly as it would at the full voltage, but it will still charge. And if then there is power coming in from the solar, that will be at a higher voltage, so it will sort of prefer, if you can sort of say that the power from the solar would get used first, and maybe I can get away without having this intelligence for the DC to DC, or the DC charging. Never mind if the power is coming from the alternator in the car, or if it is coming from a power supply of some kind. That's where I'm at right now. As I said, I got a little bit more intelligent on this here, a bit more intelligent maybe, but a little bit more informed about how these things behave, which is good. There's still a lot of stuff to understand about this, and I will have to do similar measurements to these when I actually get my lithium iron phosphate cells in, see how they behave, and if that would be a feasible solution to keep the DC charging at a lower voltage and let the solar do all it can when it can, because that's also how you want to cram as much power as absolutely possible out of the solar when you have it available, right? Whilst the DC charging source might be different, because as I've explained in a different video, I will have a lead acid battery in the boot of the car, which will absorb as much power from the alternator as possible, and then then charge the caravan battery from there by stepping up the voltage inside the car. So we'll have a high voltage on the thin wire that goes through the caravan chassis and into the battery there. Maybe such a high voltage there that I have to step it down when I'm inside the caravan. Probably the best thing to do, because then you can account for the voltage drop and everything that will happen through that line, and have one of these basically between what is coming from the car and the battery pack in the caravan. And yeah, maybe, just maybe, I can get away then without having this. But still though, from the AC charger, I'm planning to build that from an 1100 watt server power supply, possibly even two of them in series, so I get the voltage up to almost what I need, about 24 volts I should be able to get out of those. And with various modifications I might be able to get even more out of them. And then sometimes maybe you would like to cram as much power as possible into the battery in a shorter time as possible for some reason, like people do with their battery cars. They quick charge them, sort of what that would do, because the battery will, according to specifications, it should be possible to charge it at a rate of over 4 kilowatts, so you could charge the entire pack up in like 50 minutes. However, that comes with its own I would need two phases, basically one phase for each power supply. Because on the AC side there would be about 20 amps required, not accounting for losses through the power supplies and a constant current limiting thing. Yes, and so on. There you have it. That's how far I've gotten on this here lithium charging business. And this cell is dead. I'll try turning it up again and see. I've had it like this, set to a reasonable voltage here, and looked at the current, nothing. Every now and then it flickers to a 1 here, and when I brought this up to about 5 volts, I even managed to see a 2. I already said that, you know. But I don't think this cell is revivable, unfortunately. Then we have 5.3, 5.4 volts, no current, absolutely no current, 5.7, 8, almost 6 volts, and then more current seems to be flowing, but this is now severely over voltage, over the specified voltage of the thing. I'm not comfortable with this. I mean, maybe it could be. No, I don't think so. But just to finish the thought, the way I've hooked this up here, maybe I'm not getting a pure contact to only the cell. Maybe something is, the electronics here on the inbuilt charger is doing something, but I don't think so, because the tab coming out here is the negative of this here cell, and never mind what happens here. And on the other end, that is the positive side of that cell. Also, never mind what happens here. It ought to go. I mean, the electrons, they prefer to flow they take the route of least resistance, and that should be through the battery. However, the battery cell seems to have a bit of internal resistance. I wonder if we can measure that. I know that this is not how you measure internal resistance of batteries, though. Let's say we disconnect something. We turn the power off first, and then we unhook this from there. There you go. And now the voltage of the cell has risen to 3.4 volts. It's going down quickly. Yeah, down, because no current has actually gone into it. It's only the voltage that has been applied, really. But maybe if we turn this to, so here, take away a few things that we don't need there, and then we put this to resistance measurement. This is not how you measure the internal resistance of a battery. You need some sort of, as far as I've been able to ascertain, you need something that applies an alternating current through it to also be able to measure this. But it won't hurt to just attach that there and see what it is. That it is more than 200 ohms, so no wonder that no current is flowing. It's more than 20,000 ohms. It's more than 200,000 ohms. Yeah, it's pretty much not very much connected at all. Now is it? Is this working at all? Yes. Claims to have 7 ohms resistance in the leads. Whatever. If we take a healthy cell and do a similar measurement, what do we get? So here then I want to connect to this one and this one here. It's still the same, because this should be the internal resistance of this here lithium cells should be in the order of magnitude of a few milli ohms or micro ohms. But now I suppose you need that a little bit of alternating current through it as well. What was that? That was something. It might have been me completing that circuit. No, apparently I have what do you say, infinite resistance as well. Yeah, so you cannot measure the internal resistance of a lithium cell by a very simple ohm multimeter, like so. Right then, that's it. There you go. That's it for the AC, for the lithium charging learnings. There might be more lithium charging learnings. There will be more lithium charging workings, because I need to figure this out. And when you get completely different answers, and both all of them sound just as convinced that they have the correct answer, then what are you supposed to do? You need to find it out for yourself. That's what's left as an alternative. But there you have it. That will be that for now from Dr. Plurings Electronics Laboratorium. Thanks so very much for watching. Cheerio. Well, maybe that wasn't quite it from Dr. Plurings Computer Laboratory, Electronics Laboratorium, whatever, for this moment. So I've hooked this up again. I dismantled it all, but now I hooked it up again to this bad cell. And by turning the voltage up here to a level where you should probably not ever go, as in like 6 something volts I was up to, But this cell is now actually, current is actually flowing into it. I would think somewhere it is ending up. It's not getting hot. Neither is that. And I actually managed to get like 100 milliamperes through it. I'm blocking the thing with my hand. That's just how the nature of the beast, I'm afraid. But you can see the voltage sometimes. See if we can bring this up here, maybe. There. Yes. Should be somewhat legible a little, yeah, except that my hand gets in the way. Yes, I'm sorry, I don't know where to put it. I need to have good control on this here thing. Over there. Maybe. Yeah, it should be somewhat readable. Yes, and my hand. It's not in the way there, but it is in the way for the voltmeter. The thing is, this is so very much cobbled together right now. That is not very safe. Just change the camera angle, maybe. There. And that is in reverse, but that's all right. The current is actually flowing into the battery cell. So if you turn the voltage up again here, you see it rises. And maybe if I left it like this for a while, a short while, doing this bursts every now and then, you see there we get 80 milliamps at 6 volts. It's twice what the cell is rated for, you know. But if you do that, what has me a little bit hopeful about this is when I bring the voltage back down, current continues flowing. There you got 100.1 of an amp at 6 volts. It's probably not safe to be at this level for very long. Then we'll bring it back down again to a reasonable level, which should be about there. You maybe even keep it a little bit on the high side of what it should be there, 4.4 volts. You see we have a current, 0.02 of an amp, steady. So maybe, I mean, either this is cooking the electrolyte or something, this power, or it is actually charging, or something is happening. Something is happening inside this here cell. What that is, I don't know, but something is happening in there. But as it should start accepting much more current, we should see this drop to the actual cell voltage rather than being all the way up here. But okay, we do another one where we turn it up a bit. Yeah, current goes up too. Do I have a plan of what to do with this if it catches on fire? Not really, because it's hooked up a bit. But I think, yeah, I'll unhook that and then throw it outdoors. That's what I'll do. Keeping a close eye on the ammeter. 100 milliamps almost. Yeah, but that's almost 7 volts. Something is obviously very wrong with this cell. But still, this is something's happening here. I'm a bit stubborn, maybe sometimes, and should have given up on this a long time ago before I have an accident. But I just can't. Not when I'm getting somewhere. Or I don't know that I'm getting somewhere, but something is at least happening here. Now, at this rate, at a reasonable voltage, we actually have a steady flow of current, even though it is very, very small. But this should be reasonably safe, maybe to leave like this for a while. I think that maybe that's what I'll do. I'll hook my rig up my charging circuit here in a bit more of a precise manner, again as it was previously more or less, and then maybe leave it like this and just see what happens. Maybe. What if we now turn the power supply off? What voltage do we have at the cell? It still needs to discharge the capacitors in the power supply, which might take a while. No, but there you go. 3.3 volts sounds really good, except that it isn't accepting any charge at any level. Okay, well I'll rewire rewire the charging circuit as it was, or as something that is at least a bit more. Is there anything wrong with this charging circuit that you have here? Not really, except everything, of course. But yeah, it is what it is. Do we have a good connection here? We have a good connection enough for 100 milliamperes, most certainly. That's the positive coming from the power supply, and the negative of the cell is hooked up there, going through the ammeter. So to complete this circuit, I really only need to hook this lead off to the ammeter up there. There you go. And then I just want to have the voltmeter connected in a bit more of a permanent fashion as well. So we can do that. That's there. Maybe I'm probably out. Yeah, I'm a little bit out of shot, but it is alligator clips, and it is twisting wires around the probes for the multimeters. That's what this entails. Right, there you go. And then this one too. Let's see here now. That is the negative side of the thing, and the positive side of the thing is there. Maybe we could jam it in there and get the reading. Have it somewhat secure, not secure, but at least that it stays in place for. Come on. Yeah, I don't quite like to go in there as it stands right now. I need to undo that screw by a turn or two without it letting loose from the threads neatly, like that maybe. Now can we jam it in? Yeah, good enough. There you go, 3.3 volts, 3.16. Okay, turn it on. And yeah, it is, some current is flowing, which is interesting, I have to say. Something is happening here. I just can't get away from that fact that something is happening here. Turn the voltage up to very not specified within specification limits. 6 volts, 6.5, 100 milliamps. Milliamps, 120 at almost 7 volts. Someone might be yelling at the screen now, but stop this, man, you are going to have it explode in your face here in a minute now. Because even if the electrical energy in here is about nothing, yeah, but the chemical energy is the same as the electrical energy in a battery. Yeah, it sort of is. But there, okay, so we leave it here at a reasonable level, 4.3 volts. And we had 20, between 100 and 20, between 10 and 20 milliamps going into the battery. And maybe it will reach a stage here where it goes like, where this starts ramping up and this starts ramping down. Maybe. I'll leave it like this for a while and see what happens. If you don't hear back, sorry you couldn't see the ammeter there. There you go. Maybe this will be the end of it. I've already said goodbye here many times in this video now, but there you go. That's how it goes with these things when you don't know what you're doing. You have the little mouse, you can be there supervising watching the thing. Right, very good. I suppose I'll have to make a follow-up here, see what happened. But if there isn't a follow-up, if this is the end of the video, then nothing happened further. Thank you so much for watching. In that case, cheerio. Right there, ladies and gentlemen, I feel one more thing with this here cell before I give up completely on it. I did have it here on a little bit of over voltage, adjusted it up every now and then, saw that some current is actually going somewhere in the vicinity here, and turn it back down to more conservative charging voltage and so on, and now I don't think that this is going to work, but anyway, now the cell is resting at 3.4 volts, and it's not drop. What? It just went to nothing. Yeah, I think that's a glitch in my. Is that a glitch in my connection here, or is that actually the cell doing funny business? No? The cell is sort of fine there, doing its thing. So if we figure that I was going to try and hook up a load to it. I figure a load. I don't have a 3.4 load handy, but I do have this 12 volt incandescent bulb, and that ought to be something. Ought to do something, I think. Put that there. You can see what I did. I connected the probes of these two together. That would be the let's see here, how do I have this now? That is the negative coming out of the battery, is what that is, and this is the positive going into or coming out of the battery, or however you want to look at it. See if we can get that off from there. Yeah, the noise that is being generated here in the background is from my diesel refrigerator. It's a separate video that either is out or will be coming out soon on the Dr. Plurings channel. So what do we have then? We moved that one, that is not part of this. I need to think here now. Yeah, that was the that is the negative coming out of the battery. So we see the polarity reversed there on the voltmeter. Is it working? Yes, that is actually working. Great. Then I suppose we do this is to try and hook this up in some sort of permanent fashion here. The voltmeter, that is, so you can see what's going on there and there. There you go. 3.43 volts. Yeah, okay, great. And now we check. I can sort of see what I'm doing. See if we. That's the best you're going to get, I'm afraid. So if we do that, and then we touch this to there, see if anything happens. Well, the voltage goes to basically nothing, but there is. You need to have this set to current. There. It isn't lighting, I can tell you that. The voltage does drop to nothing, didn't it? Yeah, the voltage drops to nothing. We get 20 milliamps or so, to 10-20 milliamps out of it. So it's not really working now, is it? No. Okay, if we try switch this over to the healthy cell that I charged, you need to be down there, okay, and then we take that to there, I think, yes, 4 volts, yeah, there, very good. Turn that in, like, tuck that in underneath here like so we have a connection preferably. would you please stay there? Apparently not. There you should stay. Okay, very good. Now then, it should be this one, and then we do it like so. There. What? This is a little bit unstable, maybe. Yeah, I suppose it is. Is this not connected properly? We should have a voltage reading now. Yes, but this has come loose again. Come on, be there for just this bit, please. There you go. If you could stay. There, and we want this cell. As soon as I touch it, it glitches away there. Come on, mate. Would you play along? Please. No, you're not going to play along. Am I going to have to do a little jumper cable? I really don't want to. See if we can tuck this in better, maybe. Here. There, that should be a very solid, good connection to it. Right, and then we don't want to short that on that, but yeah, there. 4 volts. Now I don't expect this to light up very brightly, but I at least expect some current to flow. Oh, it does light up. I don't think it's now I'll move the camera to a different vantage point. There you go. It is shining at and this is half an amp, almost 410 milliamps to do that, but it is working. That cell is working. The current voltage drops from 3.99 to about 3.85 under load. See if we can figure out the point where. Oh, what the fuck was that? You heard that, right? It said psht. What's in all that is that was a sound that I'm not completely comfortable with. What the hell that was? Oh. No. No. That's no good, I don't think. Let's see here. Maybe these two. Yeah, there were 8 volts. So those are the 2 healthy cells, but the unhealthy cell is also in parallel. There, isn't it? I think it would be. And what was that sound that it made? Now we have. Can you see the voltmeter? No, we cannot. The mouse is keeping an eye on it, but there you go. So between these two, I actually have 11.38 volts, but that includes the bad cell. And there I have 6.20, so that ought to be 1 bad and 1 good cell. And there I only have 3 point, okay. 11.38, 3.6, 6 something. So between those two, what was it again? Was it those two? Yeah, between those two I almost have 12 volts. That including the voltage of the bad cell must be. Yes, it is including the bad cell. But in either case, just for fun and for possibly that sound I did not enjoy, really. at all, I have to say. So you can get this onto there in a relatively safe manner. Yeah, sort of. Oh, but that thing is touching there. That's probably not good. That's probably not good at all. There you go. Very good. And then let's see, hook up so you can prod the voltmeter probe in here maybe, and get it to sit there somewhat without ruining things too badly. Right, sure mate, this is sketchy to say the very least. Yes it is. Another alligator clip, please, if you wouldn't mind. I think you have one here around here somewhere that you have used previously. Yes, I don't think so. But then again, I have definitely had more of these whilst working on this. And where has it gone? Mouse, do you know where the alligator clip went? I'm lacking one. You see. Whatever, we can do it. Yeah, we can't really do it without a bit too difficult. But here, we can use this. So if you try and get this onto here without shorting it out on anything. You stupid person, what the hell are you doing now? This is not really safe. No. No, this is not an instructional video, if anyone got that impression. I don't think anyone got that impression, mate. Rather, it's quite the opposite. But you do need to find a little alligator clip, or I need something else to hold it on there for me. Just a moment here. See, what was that? There's something on the floor. Yes, there it is. I stepped on it. Here it is. So by doing this then, by somewhat connecting this here, yes, very safe. There maybe is a better way of doing this, which would be to feed the wire through the little hole in the alligator clip, at least a tiny fraction of the thing that will actually fit through the hole there. You see, like so. But even though we got the voltage up to somewhat of a reasonable level on that cell, could still not pull any power out of it whatsoever. Neither power nor current we could get out of it, really. There, if I hook that up onto there, then here should be my either positive or negative terminal. Doesn't really matter because it is an incandescent light bulb that I intend to. So that should light it, right? It did not. Oh, okay. I do not have voltage here. Yes, I have 12 volts. Yeah, if you see, check this out. There, 12 volts. What are you doing with this? Wait a minute, this is not right. No, you should. Current goes into ammeter, comes out of ammeter, the other pole of the battery, and the other pole of the thing here. That should complete the circuit, and that should do us something, but it does absolutely nothing. What if you just put these two together? That's not going to do anything because that's not a complete circuit. No, but that is a complete circuit. Okay, see if we put the voltmeter there. There we have. There, and I'm now completing the circuit with a little light bulb through the ammeter. And when I do that, voltage drops to absolutely nothing. Okay. And no current is flow. So that I suppose would include the bad cell as well, and that's why we're not getting anything out of it. If I could get only the two healthy cells, which is that one and that one, those are not connected there. Okay, and that the positive there, that goes straight to this one. Ah, right. And then where is the negative then of the also somewhat healthy battery is down here. You see, aha. Now we have something. So not know what to do. I think to maybe get the light bulb to shine here from a little battery. There, connect that like there, and that an alligator clip on it as well, and also the negative for the voltage probe onto there. If we could get that in somewhat, I think that would be good enough, right? There should be 8 volts. Yes, 8 healthy volts. That should be. And then we take this little thing. Short again. There you go. I connect that to there. Again, I really didn't like that sound that it made as I was prodding around in there. I don't think that they're supposed to make that sound under normal operations, but this is not. This is normal operations. This is. Yeah, what is this then? I don't know what this is, but there you have it. See voltage probe onto there, please. 8. It was. Oh no! Now it shorted onto something to the board. Okay, there has to be a better way. If we remove that, now this is also solidly connected here. So there, I'll try and get that. There you go. That's better. There you have nothing again. But there you sort of have 8 volts. Okay, 8 volts. And that will go to this part of the lamp. And then we come in here with the negative bit and complete the circuit. And what do we get? Oh, we get it shining at 540 milliamps, 6.64 volts. Quite a significant voltage drop there under load, I have to say. But this is now my first complete lithium circuit, lithium powered circuit that I made, sort of. Yeah, but that's it. You have 7 volts to get out of there, which is pretty reasonable, right? The nominal voltage of these lithium ion cells is 3.7 volts. 3 plus 3 is 6, and yeah, it's a bit on the low side, right? It's not too bad. But we're only drawing half an amp. Yeah. Okay, and the bulb is heating up. That is somewhat of a result, I suppose. See if we can make this reasonably safe again. There, unhook that, unplug, unhook that. And there you go. Right, see if we can probe the somewhat healthy battery that I've charged. What is that at? Nothing. Nothing. Oh mate, that's not right. Did I destroy something, or what did I do? What? I don't get it. No. I think you should quit it now, because I was using one probe from the voltmeter and one probe from the ammeter. This, if you actually use this one instead, you're going to get the voltage of that there cell, which is almost 4 volts. And the other one, the other healthy one, this one that is, that should be around underneath here somewhere. You should be able to get to it maybe. But it's not very healthy anymore. It's down to 3.7, 3.8. Okay. Well, that's okay. Because I need to charge it. Then I suppose I almost want to disassemble this thing. Since if I want to use it, I still need to get this cell out, because that's not ever going to accept the charge, and replace it. Right. I think so. There, mate. That's what you have to do. So we can pry that in there. And now we have negative, or is it a negative? Yes, that is indeed negative, coming out of that there battery cell. And that should mean positive, or rather, no, not positive, still negative coming out of the cell there. So that should give us the voltage of that cell in reverse when I put that there. Now it is 4 volts. Okay, maybe I didn't get a good connection previously. Right, I don't know, mate. Anyway, maybe I learned something. I put a load on it, but that's about it. I don't know if I'm comfortable keeping this indoors, considering that sound that it made. That psh sound. What the hell was that about? Yeah, what the hell was that about? Never mind. For the 4th or 5th time, whatever it is, here from Dr. Plurings Lithium Charging Laboratorium. Thank you so very much for watching, and cheerio, ladies and gentlemen. Have a good night.